Imagine staring up at the night sky, convinced you know what's out there, until one day, astronomers spot something so strange, so utterly inexplicable, it throws everything into question. Just last year, a team detected a mysterious object pulsing with energy in deep space, flashing like a cosmic lighthouse at random intervals. No known star, no known phenomenon could explain it. And that's just the beginning. The universe is full of events that defy logic, challenge our understanding, and remind us how much we still don't know. Today, we're diving into 25 of the most bizarre cosmic events ever recorded, phenomena so strange, they'll make you question reality itself. Think about it. We've mapped planets, charted galaxies, even captured images of black holes. But for every mystery we solve, the cosmos throws another curveball our way. Take the infamous WOW signal, a one-time burst of radio waves from deep space so powerful it was never detected again. Or the Great Attractor, an invisible force dragging entire galaxies toward it, hidden somewhere in the cosmic void. These aren't just quirks of nature, they're glaring gaps in our knowledge, cosmic puzzles begging to be solved. And that's what makes them so thrilling. This journey isn't just about listing weird space events, it's about stepping into the unknown where the rules of physics seem to bend and break. From stars that vanish without a trace to eerie signals that hint at something or someone out there, each of these 25 discoveries will leave you awestruck. So buckle up. By the time we're done, you'll see the night sky differently, not as a static map, but as a living, breathing mystery full of secrets waiting to be uncovered. Ready to have your mind blown? Let's begin. Picture this: August 15, 1977. A radio telescope in Ohio, part of the Search for Extraterrestrial Intelligence program, picks up an unusual signal from the constellation Sagittarius. For exactly 72 seconds, the telescope records a burst of radio waves 30 times stronger than the cosmic background noise. The astronomer monitoring the data, Jerry Amon, circles the reading on the printout and writes one word next to it: WOW, giving the signal its now famous name. Then, just as suddenly as it appeared, the signal vanishes, never to be detected again despite decades of searching. What made the WOW signal so extraordinary wasn't just its intensity. It matched the exact frequency scientists predicted an alien civilization might use for communication. Known as the hydrogen line, this specific radio wavelength travels through space with minimal interference, making it an ideal cosmic hello. But here's where the mystery deepens. The signal was narrowband, meaning it came from a highly focused source, unlike natural cosmic static, and its duration, exactly 72 seconds, the precise amount of time the telescope's field of view could capture it as Earth rotation carried it across the sky. Coincidence or something deliberately timed? Experts have spent decades debating possible explanations. Some argue it was a passing comet reflecting sunlight, except comets don't emit strong radio waves at that frequency. Others suggest it might have been a military satellite or secret human technology, but no known man-made source matches the signal's profile. Then there's the unsettling possibility: what if it was an alien transmission? A brief, intentional broadcast meant to catch someone's attention hours before disappearing into the void. The truth we may never know. The WOW signal remains a tantalizing enigma, a cosmic flare that ignited imaginations and then left us in the dark. It's a reminder that sometimes the universe teases us with questions we can't answer, and that's what makes astronomy so endlessly fascinating. One thing's certain: if you ever find yourself staring at the stars, wondering if we're alone, just remember 46 years ago, something out there made us go, wow. And we're still listening. Now, let's talk about a star that refuses to play by the rules: KIC 8462852, better known as Tabby's star. Discovered by NASA Kepler Space Telescope, this distant sun, nestled in the constellation Cygnus, behaves like nothing else we've ever seen. most stars flicker predictably, dimming slightly when planets pass in front of them. But Tabby's star, it dims erratically, sometimes by just 1%, other times by a staggering 22%, with no clear pattern. Imagine a light bulb that randomly flickers, not because of a power surge, but because something massive and unknown keeps drifting in front of it. That's the puzzle astronomers faced. Kepler's data revealed the star's bizarre light curve, graphs that looked less like a smooth dip and more like a jagged cliff. One theory, proposed by astronomer Jason Wright, suggested the dips could be caused by a Dyson swarm, a hypothetical megastructure built by an advanced civilization to harness the star's energy. The idea sent shockwaves through the scientific community. Could we be glimpsing evidence of alien engineering? The media ran wild with the story, dubbing it the alien megastructure star. But science thrives on skepticism. Other researchers pointed to less exotic explanations, like swarms of comets or vast clouds of interstellar dust. Recent studies have tilted toward natural causes. Observations from the Hubble and Spitzer telescopes detected uneven dimming across different wavelengths, something a solid megastructure wouldn't produce. Instead, the data suggests fine, micron-sized dust particles, possibly from a disrupted planet or a family of comets, are scattering the star's light. Yet even this explanation leaves gaps. Why is the dust so unevenly distributed? Why does the star's long-term brightness also fade over years? Tabby's star remains a cosmic riddle, balancing on the edge between the known and the unimaginable. Whether it's a swarm of comets, a fractured planet, or dare we say it, something even more extraordinary, this star challenges us to think beyond the textbook. It's a reminder that the universe doesn't owe us easy answers. Sometimes the most profound discoveries begin with a single, baffling flicker in the dark. Now let's turn our attention to something closer to home, or rather, hovering mysteriously above it. For decades, conspiracy theories have swirled around an enigmatic object dubbed the Black Knight satellite, said to be an ancient, alien-built satellite silently orbiting Earth for thousands of years. Stories claim it predates human spaceflight, that it's been watching us since the dawn of civilization, even that Nikola Tesla intercepted its signals in the late 1800s. The legend grew with grainy photographs, alleged radio transmissions, and a persistent belief that governments are hiding the truth. But what's really up there? The myth took hold in the 1950s when newspapers reported unusual radar echoes picked up by both the US and Soviet militaries. Then, in 1960, an object appeared in polar orbit, an odd trajectory for human-made satellites at the time. UFO enthusiasts latched onto these incidents, stitching them together into a grand narrative of extraterrestrial surveillance. Amateur radio operators added fuel to the fire, claiming to intercept strange, coded signals they attributed to the Black Knight. And in 1998, Space Shuttle Endeavour astronauts captured footage of a dark, irregularly shaped object drifting against the backdrop of Earth images that went viral as proof of the satellite's existence. But science tells a different story. NASA identifies the so-called Black Knight as nothing more than space debris, likely a thermal blanket lost during a spacewalk or a discarded piece of an old satellite. The infamous 1998 footage, experts confirm it shows a protective cover from Endeavour's own cargo bay, accidentally jettisoned during the mission. As for those eerie radio signals, natural cosmic noise or even human-made interference can easily mimic artificial patterns our brains are wired to find meaning in randomness. Still, the myth persists, and here's why. The Black Knight taps into something primal. The idea that we're not alone, that something, or someone might have been observing us long before we reached the stars, is irresistibly compelling. It's a modern-day fairy tale wrapped in the aesthetics of mid-century space-age intrigue. And while the evidence points to mundane explanations, the mystery endures because it speaks to our longing for the unexplained. In a universe teeming with wonders, sometimes the most fascinating stories aren't about what's real, but what we want to believe. So next time you gaze up at the night sky, remember, the truth may be out there, but the legends, they're already here. Out in the vast cosmic ocean, there are flashes so powerful, so fleeting, they outshine entire galaxies and then vanish before we can even blink. These are fast radio bursts, or FRB, some of the universe's most enigmatic signals. Lasting just milliseconds, they pack more energy than our sun emits in days. And the strangest part, we still don't know what's causing them. The first FRB was detected in 2007, buried in archival data from Australia's Parkes radio telescope. Since then, hundreds more have been recorded, each one a split-second mystery. Most erupt just once, never to repeat, like cosmic firecrackers, but one, FRB 121102, shattered that pattern. Located in a dwarf galaxy 3 billion light-years away, this burst doesn't just flash once, it repeats, firing off signals at irregular intervals. It's as if something or someone is flicking a switch over and over. So what could possibly generate such immense energy? Leading theories point to magnetars, neutron stars with magnetic fields trillions of times stronger than Earth. Picture a star so dense, a sugar cube-sized chunk would weigh as much as a mountain. Now imagine it spinning wildly, its magnetic field twisting until it snaps, releasing a blast of radio waves. But even this explanation has holes. Some FRBs seem too energetic for even magnetars to produce. Could they be colliding black holes, cosmic strings? Or, as some daringly suggest, beams from alien light sails powering interstellar voyages? The hunt for answers is on. Telescopes like CHIME in Canada scan the skies daily, catching FRBs in real time. Each new detection narrows the possibilities. Recently, astronomers traced one burst to a spiral galaxy's outskirts, not the chaotic core where magnetars usually lurk. Another seemed to glitch, its signal hiccuping in ways no natural model predicts. Every clue deepens the intrigue. Here's what makes FRBs so thrilling. They're not just cosmic oddities, they're tools. As these radio waves traverse the universe, they interact with the sparse gas between galaxies, revealing the universe's hidden structure. It's like turning on a flashlight in a foggy room. The way the beam scatters tells you about the fog itself. FRBs might even help solve one of cosmology's biggest puzzles, the missing matter problem, where half the universe's expected atoms seem to have vanished. Whether they're magnetar tantrums, alien engineering, or something beyond our current physics, FRBs remind us how little we truly understand. In a cosmos full of whispers, these are the shouts, brief, deafening, and impossible to ignore. And with every new burst, we edge closer to unraveling one of space's most electrifying secrets. Imagine an object from another star system, so alien, so unexpected, that it tears through our solar system like a bullet, defying every rule in the cosmic playbook. That's Oumuamua, the first known interstellar visitor, discovered in October 2017. Hawaiian for scout or messenger, this mysterious traveler arrived without warning, a dark, cigar-shaped rock tumbling through space at nearly 200,000 miles per hour. But what made Oumuamua truly bizarre wasn't just its origin, it was how it moved. As astronomers tracked its path, they noticed something impossible to ignore. Oumuamua wasn't just coasting on gravity's pull. It was accelerating, as if pushed by an unseen force. Natural explanations pointed to outgassing, the way comets expel gas and dust when heated by the sun, creating a tiny thrust. But here's the catch: Oumuamua showed no visible coma or tail, the telltale signs of outgassing. It looked like an asteroid but behaved like a comet, leaving scientists scrambling for answers. Could it be a new type of cosmic object, one we've never seen before? Or was there something even more extraordinary at play? Enter the controversy. Harvard astronomer Avi Loeb proposed a radical theory. What if Oumuamua wasn't natural at all? Its peculiar shape, roughly 10 times longer than it was wide, matched theoretical designs for an interstellar light sail, a spacecraft propelled by solar radiation. Add to that its unexpected acceleration and eerily reflective surface, and suddenly the idea of an alien probe didn't seem so far-fetched. The scientific community erupted. Critics argued Occam's razor, the simplest explanation, like an exotic comet, was more likely, but Loeb countered, shouldn't we at least consider the possibility? After all, Oumuamua didn't just break the mold, it shattered it. The truth may lie in the details we'll never get. By the time Oumuamua was spotted, it was already speeding away, too faint and distant for further study. Its brief visit left us with more questions than answers. Was it a fragment of a shattered planet, a hydrogen iceberg, or, as some still wonder, a relic of intelligence far beyond our own? One thing's certain, Oumuamua rewrote the rules. It proved interstellar objects could visit our cosmic neighborhood, opening the door to future discoveries. And it reminded us that sometimes the most profound mysteries come in the most unexpected packages. A silent traveler glimpsed for just a moment, leaving us to wonder what else might be out there drifting between the stars. So the next time you look up, remember, the universe doesn't just send us comets and asteroids. Sometimes it sends enigmas, and Oumuamua, it's just the beginning. Deep in the cosmos, hidden behind the thick veil of stars and dust in our own Milky Way, lurks something massive enough to bend the paths of entire galaxies, a gravitational monster known as the Great Attractor. Imagine a force so powerful it's dragging thousands of galaxies, including our own, toward it at speeds of over 14 million miles per hour. This isn't just cosmic curiosity, it's a full-blown mystery that's been puzzling astronomers since the 1970s. The story begins with motion. When scientists first mapped the large-scale movement of galaxies, they noticed something strange. Everything in our galactic neighborhood, including the Milky Way, seemed to be streaming toward a single point in space, far beyond what we could see. The culprit, a gravitational anomaly so immense it warps the very fabric of the universe around it. But here's the catch: it lies directly behind the Milky Way's zone of avoidance, a region where our galaxy's dense gas, dust, and stars block nearly all visible light from beyond. It's like trying to spot a lighthouse through a hurricane, nearly impossible with traditional telescopes. That's where X-ray astronomy comes in. Since visible light can't pierce the zone of avoidance, scientists turn to X-ray telescopes like NASA Chandra and Europe's XMM Newton, which detect high-energy emissions from hot gas and massive structures. Peering through the cosmic fog, they uncovered a staggering truth. The Great Attractor isn't just one object, it's part of an enormous supercluster called Laniakea, a web of galaxies spanning 500 million light-years. At its heart sits the Norma Cluster, a dense gathering of galaxies with the combined mass of 1,000 Milky Ways, acting as the anchor for this cosmic river of motion. But the plot thickens. Even Laniakea's immense gravity can't fully explain the Great Attractor's pull. There's something beyond it, an even larger structure, possibly the Vela supercluster or the mysterious Shapley Attractor, tugging at everything in its reach. It's a cosmic tug-of-war on a scale so vast it redefines our place in the universe. We're not just orbiting the Sun or even the center of the Milky Way. We're part of a grand gravitational dance, swept along in a current that stretches across hundreds of millions of light-years. What makes this discovery so thrilling is what it reveals about the universe's hidden architecture. For decades, we saw galaxies as isolated islands. Now we know they're threads in a sprawling cosmic tapestry woven together by gravity's invisible hand. The Great Attractor isn't just pulling galaxies, it's pulling back the curtain on the universe's best-kept secrets. And as telescopes grow more advanced, who knows what other colossal structures might be lurking just out of sight, waiting to rewrite the story of our cosmos once again. Take a step back and picture the universe in motion, not just planets orbiting stars or galaxies spinning, but something far grander. Across unimaginable distances, entire clusters of galaxies are streaming in the same direction, like leaves caught in a cosmic current. This isn't just random drift, it's a coordinated movement toward something outside the known universe. Astronomers call it dark flow, and it's one of the most unsettling mysteries in modern cosmology. The discovery came from studying the cosmic microwave background, the afterglow of the Big Bang. By mapping tiny temperature fluctuations in this ancient light, scientists can track how galaxy clusters move through space. But when researchers analyzed data from hundreds of clusters, they found something impossible. These massive structures were all racing toward the same patch of sky at speeds exceeding 2 million miles per hour. The kicker, there's nothing there, no supercluster, no dense knot of matter, nothing visible in our observable universe capable of exerting such a gravitational pull. It's as if the universe itself is tipping toward some unseen horizon. Theories attempting to explain dark flow venture into the realm of the extraordinary. One possibility, the gravitational tug of a neighboring universe. If our cosmos is just one bubble in a vast multiverse, as inflationary models suggest, then the massive structures beyond our cosmic horizon could be warping spacetime enough to drag galaxies toward them. Imagine two soap bubbles floating close together. Even if they never touch, the gravity of one could subtly distort the other. That's the essence of dark flow, a ghostly fingerprint of something else, something beyond. Skeptics argue it could be a statistical fluke or an artifact of incomplete data, but multiple studies, including observations from NASA, Wilkinson Microwave Anisotropy Probe, and the Planck satellite, have reinforced the anomaly. Simulations of large-scale cosmic structure only deepen the puzzle. When scientists model the universe's matter distribution, nothing reproduces the observed flow unless they add an unimaginably vast concentration of mass outside the simulation's boundaries, a place we can't see, let alone comprehend. What makes dark flow so electrifying is what it implies about reality. If confirmed, it suggests our universe isn't just expanding, it's being pulled. The very fabric of spacetime might be stretching toward uncharted realms, hinting at dimensions and structures we've only dreamed of. It's a humbling reminder that no matter how much we map, how much we measure, the cosmos always keeps its greatest secrets just out of reach, teasing us with whispers from the dark. Rising from the heart of our galaxy like two colossal hourglasses, stretching 25,000 light-years into space, are the Fermi Bubbles, twin towers of high-energy gamma rays that defy everything we thought we knew about the Milky Way. Discovered in 2010 by NASA, a Fermi Gamma Ray Space Telescope, these gargantuan structures glow with the energy of 100,000 supernova, yet they're invisible to the naked eye, detectable only through their eerie gamma-ray haze. Picture two vast, symmetrical lobes, each one towering over our galactic disk, as if the universe itself blew a pair of cosmic soap bubbles and then pumped them full of pure radiation. What could possibly create such massive, energetic formations? The leading suspect sits at the very center of the Milky Way, Sagittarius, a star, our galaxy's supermassive black hole. Astronomers theorize that millions of years ago, this sleeping giant might have woken in a violent feeding frenzy, gorging on stars and gas until it belched out two opposing jets of plasma at nearly the speed of light. These jets, slamming into the sparse gas of intergalactic space, could have carved out the bubbles we see today, their shockwaves accelerating particles to energies we still struggle to explain. It's a cosmic echo of past fury, a black hole's ancient temper tantrum frozen in time. But there's a twist. Not everyone's convinced. Some researchers argue the bubbles are too symmetrical, too perfectly aligned with the galaxy's core for a chaotic black hole outburst. Could dark matter be the culprit? If particles of this mysterious substance collide and annihilate near the galactic center, they'd release torrents of gamma rays, potentially sculpting these vast structures. It's a tantalizing possibility, one that could turn the Fermi Bubbles into a roadmap for unraveling dark matter's secrets. Then there's the scale. To grasp just how massive these bubbles are, imagine this. If they were visible in our night sky, they'd span half the width of the Big Dipper. The energy required to create them staggers the mind. Some calculations suggest the equivalent of 100,000 suns converted entirely into pure radiation. And yet, the most astonishing part, they might not be unique. Similar structures have been spotted in other galaxies, hinting that this could be a universal phase in galactic evolution, a violent rite of passage for spiral galaxies like our own. What makes the Fermi Bubbles so mesmerizing isn't just their size or their mystery, it's what they represent. They're a snapshot of our galaxy's volatile past, a reminder that even the Milky Way, that familiar swirl of stars, has a hidden, explosive history. Whether forged by a black hole's rage or the whisper of dark matter, they challenge us to rethink how galaxies live, breathe, and sometimes erupt. And as we peer deeper into their gamma-ray glow, we're not just studying distant energy, we're reading the Milky Way's autobiography, one violent chapter at a time. So the next time you gaze toward the constellation Sagittarius, remember, beneath those familiar stars, hidden in plain sight, two towering ghosts of radiation rise into the void, silent, immense, and waiting to reveal their secrets. In the vast tapestry of cosmic oddities, few objects captivate astronomers quite like the Red Rectangle Nebula, a structure so geometrically precise, it looks less like a celestial formation and more like an otherworldly artifact. Nestled about 2,300 light-years away in the constellation Monoceros, this glowing, blood-red X-shape defies the chaotic beauty of most nebulae. While cosmic clouds typically sprawl in organic swirls, the red rectangle stands apart with its near-perfect symmetry, as if etched by some celestial draftsman. But its striking appearance is just the beginning of the mystery. At its heart lies a dying binary star system known as HD 44179. One star, nearing the end of its life, has begun shedding its outer layers while its smaller companion whips around it in a tight orbit. This gravitational dance sculpts the expelled gas and dust into two opposing cones like twin ice cream cones pointed tip to tip, creating the nebula's iconic X-shape when viewed from Earth. But what really sets the red rectangle apart isn't just its structure, it's what's inside. Hubble's spectral analysis revealed something unexpected. Vast quantities of crystalline silicates, dust grains aligned with such uniformity, they glow like microscopic mirrors under infrared light. This crystalline dust is a cosmic paradox. In most of space, silicate particles are amorphous, jagged, and disordered, battered by radiation over eons. Yet here, they're arranged in perfect lattices, as if forged in the controlled conditions of a laboratory. How, one theory suggests the binary star's fierce ultraviolet radiation and shockwaves might be annealing the dust, reheating and realigning it into crystalline form. It's a process akin to blacksmithing on a cosmic scale, where stellar winds hammer chaos into order. Then there's the color. The nebula's deep crimson hue comes from an even rarer ingredient, complex hydrocarbon molecules called polycyclic aromatic hydrocarbons, or PAH. These organic compounds, often found in soot, are oddly abundant here, fluorescing red under the star's intense UV light. Some scientists speculate the red rectangle could be a cosmic factory for probiotic chemistry, a place where the raw ingredients for life assemble in the void. Hubble's breathtaking images add another layer of intrigue. Near the nebula's center, concentric ripples like tree rings hint at periodic outbursts from the dying star, ejecting material in rhythmic pulses. And towering above it all, ladder-like rungs of dust stretch vertically, a feature so unique astronomers still debate its origin. Could it be the shadow of an unseen disk? Or the imprint of magnetic fields guiding the nebula's growth? The red rectangle doesn't just challenge our understanding of nebulae, it blurs the line between chaos and order. In a universe ruled by randomness, here's a structure that seems designed. Whether it's the product of binary stars' precise choreography, a laboratory for alien chemistry, or something even stranger, one thing's certain. This cosmic gem reminds us that sometimes the universe's most profound mysteries come in the most unexpected shapes, sharp angles and all. There's a place in the universe where the night sky wouldn't just be dark, it would be nearly empty, a void so vast and barren it defies everything we know about cosmic structure. Nestled in the constellation Boötes lies a spherical chasm of nothingness stretching 330 million light-years across, a region astronomers call the Boötes Void. To put that in perspective, if our Milky Way were placed at its center, the nearest edge would be 50 times farther away than the Andromeda Galaxy. And yet, within this unimaginable volume, there are only around 60 galaxies, when there should be thousands. It's as if someone took a cosmic eraser and scrubbed away nearly everything in this corner of space. The Boötes Void isn't just empty, it's wrong. The universe at large scales is supposed to look like a sponge, filaments and clusters of galaxies woven around bubble-like voids. But those voids are typically 100 million light-years wide, peppered with galaxies at their edges. The Boötes Void is different. It's 3 times larger than it should be, and its scarcity of galaxies is so extreme, it initially seemed like a statistical impossibility. When astronomer Robert Kirshner first mapped it in 1981, even he doubted the data. Could this really be a hole in the universe or just a trick of incomplete observations? Decades later, advanced telescopes confirmed the void's eerie emptiness, but the deeper mystery remains. Why? One unsettling theory suggests the void might be evidence of colliding universes, a bruise left by a parallel cosmos brushing against ours during the Big Bang. Others propose it's the imprint of an ancient, hyper-advanced civilization that somehow cleared the region, though most scientists dismiss this as wild speculation. The leading hypothesis, a perfect storm of cosmic expansion and gravitational dynamics. Early in the universe's history, matter might have drained from this region like water from a bathtub, pulled toward denser areas by gravity's tug, leaving behind an overgrown void. Yet even this explanation feels incomplete. Computer simulations struggle to reproduce a void this large without invoking exotic physics. Some models hint at dark energy, the mysterious force accelerating the universe's expansion, acting unevenly, stretching certain regions faster than others. Others wonder if the Boötes Void isn't entirely empty but filled with invisible dark matter, warping space in ways we can't yet detect. What makes this cosmic desert so mesmerizing isn't just its size, it's the contrast. While the Boötes Void yawns open with nothingness elsewhere in the universe, galaxies packed together in dazzling clusters like the Coma or Virgo superclusters, where thousands of galaxies swirl in a gravitational ballet. The difference is staggering, one patch of sky teeming with starlight, another almost devoid of it. It's a reminder that the universe isn't just vast, it's uneven, full of puzzles that force us to question our most basic assumptions. For now, the Boötes Void remains a silent enigma, a blank spot on the cosmic map that whispers of mysteries we're only beginning to unravel. Whether it's a statistical fluke, a relic of the Big Bang, or something even stranger, one thing's certain. In a universe that's supposed to be full, sometimes the most profound questions come from the places where nothing is. On the evening of March 13, 1997, thousands of people across Arizona looked up to see something that would haunt them for decades, a formation of light so bizarre, so wrong, it sparked one of the most credible mass UFO sightings in history. The event, now known as the Phoenix Lights, unfolded in 2 chilling acts. First, a V-shaped cluster of amber orbs, each the size of a jumbo jet, glided silently over Phoenix at treetop level, blotting out stars as it passed. Witnesses described it as a single massive craft, dark and triangular, with lights embedded along its edges. Then, hours later, a second set of lights appeared near a military range, suspended in the sky like a string of glowing beads. What followed was a frenzy of confusion, cover-ups, and a question that still echoes today. What really flew over Arizona that night? The sheer volume of eyewitnesses from pilots and police officers to former Governor Fife Symington lends the event undeniable weight. One air traffic controller logged official reports of an unidentified object larger than 5 football fields, moving at a speed no known aircraft could match. A retired Air Force lieutenant colonel described it as otherworldly, while dozens of residents in nearby towns like Prescott and Dewey reported the same massive V-shape hours before it reached Phoenix. The consistency of these accounts is staggering, especially considering the era before smartphones and viral videos. This wasn't a handful of blurry photos, it was thousands of people, many with military or aviation backgrounds, agreeing on details no conventional aircraft could explain. Then came the official response. Weeks later, the military claimed the second set of lights were simply flares dropped during training exercises at the Barry Goldwater Range. But the explanation unraveled under scrutiny. Flares don't hover motionless for minutes, they flicker, descend, and burn out. Witnesses who'd seen military flares before immediately rejected the theory. Even more damning, declassified documents later revealed the flares were dropped after the initial reports, suggesting the military scrambled to create a cover story. As for the first, larger craft, officials offered no explanation at all. Years later, former Governor Symington, who initially mocked the incident, admitted he'd seen the object too, calling it otherworldly in nature. Recreations and investigations only deepened the mystery. In 2008, a team of optical scientists analyzed video footage, concluding the lights exhibited none of the characteristics of flares. Their movement, luminosity, and duration defied physics. Meanwhile, retired Air Force personnel came forward with whispers of experimental aircraft, black projects like the rumored Aurora spy plane. Could the Phoenix lights have been a secret military test? Possibly. But then why fly it low over a major city, guaranteeing witnesses? And why the eerie silence reported by so many? No engine roar, no sonic booms, just a ghostly glide through the desert sky. What makes the Phoenix lights endure isn't just the unanswered questions, it's the cultural aftershocks. This wasn't a lone farmer spotting lights in a field. It was an entire state confronted with something beyond their understanding. The event shattered the stigma around UFO reports, pushing the topic into mainstream discourse. And with the recent declassification of military UFO footage, it's clearer than ever that sometimes the truth isn't just stranger than fiction, it's hovering right above us, waiting to be seen. There's a ghostly glow that haunts the pre-dawn or post-sunset sky, a faint triangular radiance stretching upward from the horizon, often mistaken for the first light of dawn or the last remnants of twilight. This is the zodiacal light, a celestial phenomenon that has puzzled skywatchers for centuries. Visible only under the darkest conditions, this ethereal beam traces the same path across the sky as the sun, moon, and planets, the ecliptic, leading ancient astronomers to weave it into myths of celestial fire or divine pathways. But the truth behind this glow is far stranger than fiction, and it's only recently that we've begun to unravel its secrets. For years, scientists believed the zodiacal light came from a vast cloud of dust lingering in the inner solar system, debris left behind by comets and asteroid collisions. Observations seem to support this, tiny particles scattering sunlight, creating a diffuse glow along the ecliptic plane. But then came the twist. When NASA Juno spacecraft journeyed toward Jupiter, its sensitive star tracking cameras picked up something unexpected. Far beyond where the dust cloud should have ended, the spacecraft detected a faint but persistent haze of particles. The source, Mars, here's where the mystery deepens. Juno's data revealed that the red planet's intense dust storms, like the planet-wide tempest in 2018 that silenced the Opportunity rover, were ejecting fine particles into space. Solar radiation then pushed this dust into a sprawling trail that stretches hundreds of millions of miles, intertwining with the traditional zodiacal dust cloud. Suddenly, the zodiacal light wasn't just a static feature of the solar system, it was a dynamic, ever-changing phenomenon shaped by the weather patterns of distant worlds. Historical records add another layer of intrigue. Medieval Arab astronomers documented the zodiacal light as false dawn, while Renaissance scholars like Cassini theorized it was sunlight reflecting off a swarm of tiny moons. Even 20th century models underestimated its complexity, assuming the dust was evenly distributed. But time-lapse photography reveals the truth: the zodiacal light isn't uniform. It pulses, shifts, and occasionally flares, evidence of fresh dust injections from events like comet flybys or Martian storms. What makes this discovery so compelling is how it reshapes our understanding of the solar system's interconnectedness. Mars, once seen as a barren neighbor, is actively contributing to a phenomenon visible from Earth. Future missions might even sample this interplanetary dust, uncovering clues about Martian geology without landing a single rover. And for amateur astronomers, the zodiacal light is no longer just a pretty glow, it's a cosmic breadcrumb trail, leading us to revelations about the hidden dynamism of our celestial backyard. So the next time you find yourself under a dark, moonless sky, look for that faint, otherworldly radiance. It's not just dust, it's a whisper from Mars, a reminder that even the quietest corners of the solar system are alive with motion and mystery. And thanks to Juno, we now know the universe's subtlest glow might just be its most talkative. For decades, cosmologists faced a cosmic detective story with a baffling twist. Half the universe's ordinary matter had simply vanished. Not dark matter, not exotic particles, but the protons and neutrons that make up everything we see: stars, planets, even our own bodies. Theoretical models insisted this missing baryon problem had to be solved. The math demanded it. Yet every telescope pointed at the sky came up short, unable to account for roughly 50% of the universe's expected normal matter. It was as if someone had erased half the ingredients from a recipe but left the final dish miraculously intact. Then came the breakthrough, one that didn't involve new telescopes or exotic physics, but a radical shift in perspective. Astronomers realized they'd been searching in all the wrong places. Instead of looking for dense clusters of gas or glowing stars, they turned their attention to the faint, wispy tendrils of the cosmic web, the vast network of filamentary structures stretching between galaxies. Here, in these nearly invisible threads, lurked the answer: the warm, hot intergalactic medium, or WIM. Imagine the universe's large-scale structure as a sponge, with galaxies clinging to the intersections of its porous framework. The spaces between far from empty. Simulations predicted that these voids should be threaded with diffuse million-degree gas, matter so hot it emits almost no visible light, yet so thinly spread it barely registers on detectors. Spotting something this faint required ingenuity. Scientists found their solution in distant quasars, the brilliant cores of active galaxies whose light acts like a cosmic flashlight. As this light journeys to Earth, it passes through WIM filaments which absorb specific wavelengths. Like a fingerprint left on glass, these absorption lines reveal the presence and composition of the gas. The evidence mounted when the Hubble Space Telescope and X-ray observatories like Chandra combined forces. Hubble's ultraviolet vision caught the WIM faint absorption signatures, while Chandra detected traces of oxygen ions, atoms stripped of electrons glowing in X-rays. Together, they painted a picture of a universe webbed with these elusive filaments hiding in plain sight. The numbers matched. The WIM diffuse gas accounted for the missing baryons, solving one of cosmology's most persistent puzzles. But the story doesn't end there. Discovering the WIM wasn't just about checking a box, it reshaped our understanding of cosmic ecology. These filaments aren't just storage units for matter, they're dynamic rivers funneling gas into galaxies and fueling star formation. Supercomputer simulations now show how shockwaves from colliding galaxy clusters heat the WIM, while dark matter's gravity sculpts its distribution. It's a delicate balance, too dense and the gas would cool into new galaxies, too sparse and it would vanish entirely. The fact that we exist at all might hinge on this hidden scaffolding. What makes the WIM so extraordinary isn't just its role in balancing the cosmic books, it's the way it forces us to rethink observation itself. For centuries, astronomy relied on light. But some of the universe's most vital structures reveal themselves only through shadows, whispers, and the subtle bending of distant starlight. The missing baryons were never truly gone, they were just waiting for us to learn how to see. And with next-generation telescopes like the James Webb Space Probe peering deeper into the infrared, who knows what other invisible threads we'll find woven through the darkness. In the vast cosmic menagerie of galaxies, there's one that defies every expectation, a shadowy enigma known as Dragonfly 44. Discovered in 2015 by a team using the Dragonfly telephoto array, this celestial oddity lurks in the Coma cluster, 330 million light-years away. At first glance, it's unremarkable, a faint, wispy smudge of light, barely visible against the backdrop of space. But peer closer and the truth emerges. Dragonfly 44 is a galaxy built almost entirely of dark matter, a ghostly silhouette where the ordinary rules of cosmic structure simply don't apply. What makes this galaxy so bizarre isn't just what's there, it's what isn't. While the Milky Way dazzles with hundreds of billions of stars, Dragonfly 44 has just 1% as many, scattered so thinly they barely register. Yet despite this lack of visible matter, the galaxy weighs as much as the Milky Way. How? The answer lies in its monstrous halo of dark matter, an invisible scaffold accounting for 99.99% of its mass. Imagine a galaxy where the stars are mere streetlights flickering in a vast, empty city, while the real structure, the roads and buildings, are made of something we can't see. That's Dragonfly 44, a cosmic illusion hiding in plain sight. The discovery sent shockwaves through astronomy. Galaxies this massive simply shouldn't exist without the gravitational glue of stars and gas to hold them together. Computer simulations struggle to recreate such an object without it crumbling apart. Yet Dragonfly 44 isn't alone. Dozens of similar, ultra-diffuse galaxies have since been found, each one a shadowy counterpart to the vibrant spirals we're familiar with. Some theories suggest they're failed galaxies where star formation fizzled out early, leaving behind dark matter husks. Others propose they're the remnants of violent collisions, their stars ripped away by gravitational tides while their dark matter cores endured. The implications are profound. If dark matter can sculpt galaxies this massive yet this faint, it forces us to rethink how cosmic structures evolve. Traditional models assume galaxies grow by accumulating gas, birthing stars, and shining brightly. But Dragonfly 44 suggests an alternate path, one where dark matter dominates, quietly assembling titanic frameworks that barely glimmer with light. It's a parallel universe of galaxies, invisible to traditional surveys, lurking in the darkness. And then there's the haunting question, what else is out there? Dragonfly 44 was found only because its stars, though few, are unusually clustered. Without that fluke, it might have remained undetected forever. How many other dark galaxies drift unseen, rewriting the story of cosmic evolution from the shadows? Future telescopes, like the Vera Rubin Observatory, aim to find out, scanning the skies for more of these spectral giants. Dragonfly 44 isn't just a curiosity, it's a window into the universe's hidden architecture. Where the Milky Way blazes with stars, this ghostly counterpart whispers of the unseen forces shaping our cosmos. It's a reminder that sometimes the most profound discoveries aren't the brightest, they're the ones that force us to question everything we thought we knew. Imagine stumbling upon a cosmic structure so enormous, it dwarfs entire galaxies, yet it's invisible to optical telescopes, revealing itself only through the faintest whispers of radio waves. That's exactly what happened in 2019 when astronomers scanning the sky with Australia's ASCAP radio telescope spotted something unprecedented. Odd radio circles, or ORC, gigantic, ghostly rings of radio emission, each one spanning hundreds of thousands of light years. To put that in perspective, if one of these rings replaced the Milky Way, its outer edge would stretch halfway to Andromeda. But here's the real kicker. When researchers pointed optical telescopes at the same patches of sky, they saw nothing. Just empty space where these colossal rings should be. The mystery only deepened with closer study. These ORCs aren't just big, they're perfectly symmetrical, like smoke rings blown into the cosmos by some unseen giant. Only a handful have been detected so far, each one hovering around a distant galaxy's core like a halo. But what's creating them? One leading theory points to supermassive black holes. When two galaxies merge, their central black holes can spiral together, unleashing titanic shockwaves that ripple through intergalactic gas, lighting it up in radio waves. Another possibility, starburst galaxies, those undergoing frenzied star formation, might blast out galactic winds so powerful they carve bubbles into the surrounding medium, leaving behind these eerie rings. Yet neither explanation fits perfectly. The energy required to produce ORCs exceeds anything we've seen from black hole mergers or starbursts. Some researchers speculate they could be the aftermath of a new, unknown class of cataclysmic event, perhaps quasar tsunamis, where dying quasars expel their final energy in a spherical burst. Others wonder if we're seeing the echoes of a long-ago event, like a black hole's ancient feeding frenzy, its shockwaves finally reaching us billions of years later. What makes ORCs so tantalizing isn't just their scale, it's what they represent. These might be the first visible traces of processes we've only theorized, the invisible physics shaping galaxies behind the scenes. Radio telescopes, once sidelined as niche tools, are now uncovering a hidden layer of the universe, one where the most dramatic events leave no visible trace, only faint ripples in the cosmic dark. And with new arrays like the Square Kilometre Array coming online, who knows how many more of these spectral rings are waiting to be found. Until then, ORCs remain a reminder. Sometimes the universe's grandest designs are written in ink we're only just learning to read. For centuries, observers have documented eerie flashes of light flickering across the moon's surface, brief, unexplained bursts of brightness that appear and vanish without warning. These transient lunar phenomena, or TLP, range from localized glows to sudden flashes bright enough to be seen with amateur telescopes. And while some can be explained by meteorite impacts or solar reflections, others defy clear explanation, sparking debates about hidden lunar activity that shouldn't exist on a supposedly dead world. One of the most famous TLP events occurred in the summer of 1969, just weeks before Apollo 11's historic landing. Astronomers at the Lowell Observatory in Arizona reported a brilliant flash inside the moon's Aristarchus crater, a region notorious for such anomalies. NASA, wary of unknown risks to their astronauts, scrambled to investigate. But by the time Apollo 12's crew surveyed the area months later, all they found was silence, no trace of gases, no fresh impact scars, just the same ancient dust. Theories abounded. Could electrostatic charges be sparking lunar dust storms? Was trapped radioactive radon gas seeping through fissures? Or were these flashes evidence of something far stranger? Modern technology has only deepened the puzzle. High-resolution telescopes and lunar orbiters have captured TLPs in real time, like the 2013 event where observers in Spain recorded a flash lasting 8 full seconds with an energy output equivalent to half a ton of TNT. Yet follow-up scans found no new crater. Even more perplexing are the dark TLPs, where patches of the lunar surface temporarily dim, as if something briefly swallowed the sunlight. Some researchers speculate these could be subsurface collapses, creating temporary voids that scatter light differently. others wonder if pockets of volatile ices, buried for eons, are sublimating into space when sunlight hits them at just the right angle. The push to solve these mysteries is gaining momentum. Proposed lunar observatories like the European Space Agency's planned Moon Station telescope aim to monitor TLPs continuously, free from Earth's atmospheric interference. Meanwhile, private ventures are deploying networks of small, AI-powered telescopes to triangulate flashes in real time. The goal, to build a comprehensive catalogue of these events, searching for patterns that might reveal their origins. One tantalizing possibility ties TLPs to the Moon's volcanic past. While the Moon hasn't erupted in millions of years, traces of radioactive elements like thorium and uranium linger beneath its surface. If these elements cluster in certain areas, they could generate heat enough to release trapped gases in sporadic bursts. Infrared scans from NASA, a lunar reconnaissance orbiter, have indeed spotted warm spots in TLP-prone regions, hinting at residual thermal activity. Yet the most electrifying theory comes from a small but passionate group of researchers. What if some TLPs aren't natural at all? The idea of lunar outposts, whether ancient or extraterrestrial, has long been dismissed as fringe. But with governments and corporations racing back to the Moon, the question lingers, could some flashes be signs of something more than geology? After all, if even a fraction of TLP reports defy conventional explanation, that leaves room for possibilities we've barely begun to consider. Until we return to the Moon with instruments capable of sniffing out gases, measuring seismic tremors, and scanning for hidden heat sources, TLPs will remain one of astronomy's most enduring enigmas. They remind us that even our nearest celestial neighbor holds secrets, flashes in the dark that could rewrite our understanding of the Moon's past and even its future. So next time you gaze at that familiar gray orb, remember, it might not be as silent as it seems. Deep beneath the Antarctic ice, where temperatures plunge to -40 degrees and the weight of 2.5 kilometers of glacial frost presses down, lies one of science's most unlikely detectives, the Ice Cube Neutrino Observatory. On September 22, 2017, this subterranean labyrinth of over 5,000 optical sensors captured something extraordinary. A single, high-energy neutrino streaking through the ice with the force of a Major League fastball. But this wasn't just another cosmic ghost particle, it carried an address. By tracing its path backward, astronomers pinpointed its origin to a cosmic monster 4 billion light-years away, a supermassive black hole devouring matter in the heart of a blazar called TXS 0506+056. Neutrinos are the universe's most elusive travelers, near massless particles that slip through planets like moonlight through a window. Trillions pass through your body every second, leaving no trace. But when one like this, packing several hundred trillion electron volts, slams into the ice, it creates a subatomic shockwave, a brief, telltale flash of blue light called Cherenkov radiation. Ice Cube's sensors lit up, capturing the neutrino's trajectory with eerie precision. For the first time, humanity had not just detected a neutrino from deep space, but matched it to the violent engine that birthed it. This discovery marked the dawn of multi-messenger astronomy, a revolutionary way of studying the cosmos by combining different messengers like light, gravitational waves, and now neutrinos. Each tells a different part of the story. Light shows us the surface, gravitational waves reveal collisions. Neutrinos, they're the direct fingerprints of cosmic accelerators, unaltered by magnetic fields or dust. When Ice Cube's alert went out, telescopes worldwide swiveled toward the blazar. Sure enough, it was in the throes of a violent outburst. Its jet of particles and radiation pointed directly at Earth. The neutrino wasn't a fluke. It was a bullet fired from one of the universe's most powerful guns. The implications are staggering. Blazars like TXS 0506+056 are thought to be among the primary sources of high-energy cosmic rays, particles that bombard Earth with energies far beyond anything our most powerful colliders can produce. But cosmic rays being charged get twisted by magnetic fields during their journey, obscuring their origins. Neutrinos, though, travel straight, their paths unswerving. By combining neutrino data with gamma-ray and optical observations, scientists can now reverse engineer the workings of these distant powerhouses, uncovering how black holes transform matter into the universe's most energetic projectiles. What makes this event even more remarkable is the sheer improbability of catching it. IceCube detects roughly 10 high-energy neutrinos a year that hint at cosmic origins, but only one in decades has been matched this definitively to its source. It's like finding a single grain of sand-sized meteorite in the Sahara Desert, then tracing it back to the exact crater on Mars where it was launched by an ancient impact. The odds are astronomical, which is why this detection has opened a new window onto the universe's most extreme environments. As multi-messenger astronomy matures, the potential grows. Future upgrades to IceCube, alongside next-gen observatories like KM3NT in the Mediterranean, could turn these chance detections into routine science. Imagine a network of neutrino telescopes tracing cosmic rays back to their birthplaces, or catching gravitational wave events in tandem with neutrino bursts, revealing the inner mechanics of merging neutron stars. The universe is talking to us in multiple languages, and for the first time, we're learning to listen to all of them at once. So the next time you hear about a ghost particle, remember, these ethereal messengers are more than just cosmic curiosities. They're the silent witnesses to the universe's most violent spectacles, carrying secrets from places light alone can never fully reveal. And thanks to a frozen detector at the bottom of the world, we're finally beginning to decode their whispers. We think of space as vast but relatively even galaxies scattered like flour across a table. But what if we're sitting in a hole, a cosmic bubble so big we've only just realized we're inside it? This is the KBC void, a proposed underdensity in our cosmic neighborhood, stretching over 2 billion light-years across. Named after astronomers Keenan, Barger, and Cowie, who first identified it in 2013, this potential void suggests our local universe is far emptier than it should be, and that might be throwing off some of our most fundamental measurements of reality itself. The evidence comes from painstaking 3D maps of nearby galaxies. When astronomers measured the distribution of galaxies within a few billion light-years, they noticed an unsettling pattern. Fewer galaxies than expected, with densities dropping by up to 20% compared to the cosmic average. It's like living in a rural valley while the rest of the universe thrives in bustling cities. If true, this underdensity would have profound implications. The expansion rate of the universe, the Hubble constant, might be skewed because we're sitting in a low-gravity bubble where the tug of surrounding matter is weaker. Think of it as measuring the speed of a river's current from inside a calm eddy. You'd underestimate the true flow. Not everyone's convinced. Critics argue that galaxy surveys are inherently patchy, and what looks like a void might just be incomplete data. After all, mapping the universe is like reconstructing a forest from scattered photos. Some areas will always look emptier by chance. The debate hinges on observational biases. Are we truly in a void, or are we missing faint galaxies that blend into the background? Surveys like the Sloan Digital Sky Survey have tried to settle this, but the results remain tantalizingly ambiguous. What makes the KBC void so compelling is how it challenges cosmology's Copernican principle, the idea that our place in the universe isn't special. If we're inside a genuine underdensity, it means the universe isn't as uniform as we thought, at least not on the largest scales. Other voids, like the Boötes void, are vast but distant. The KBC void would be unique because we're inside it, making its potential effects personal. Some models even suggest this could resolve the Hubble tension, the nagging discrepancy between different measurements of the universe's expansion rate. Maybe the numbers don't agree because we've been measuring them from inside a cosmic anomaly, yet the stakes are high. if the KBC void is real, it could mean dark energy's influence varies depending on where you are, undermining the assumption that the universe's expansion is the same everywhere. Alternatively, it might hint at exotic physics like dark matter interacting in unexpected ways or large-scale gravitational waves warping spacetime. Future telescopes like the Vera Rubin Observatory will scan deeper and wider, hunting for more galaxies to confirm or refute the void's existence. For now, the KBC void remains a tantalizing what if. Whether it's a statistical fluke or a paradigm-shifting discovery, it forces us to question our cosmic address. Are we in an average neighborhood, or does the universe have a quiet corner with our name on it? The answer could rewrite not just our place in the cosmos, but our understanding of its very fabric. In the constellation Ursa Major, nestled among the familiar stars of the Big Dipper, a cosmic oddity defied every rule in the astrophysics playbook. It started like any other supernova, a sudden spike in brightness as the Palomar Transient Factory Survey scanned the night sky in September 2014. Designated IPTF-14 HLS, this exploding star should have flared brilliantly for a few months before fading into obscurity. But IPTF-14 HLS didn't play by the rules. Instead of dimming, it kept burning and burning and burning. For over 600 days, this stellar enigma pulsed like a cosmic strobe light, dimming and rebrightening at least 5 distinct times, a supernova that refused to die. What makes this zombie star so baffling isn't just its longevity, it's how thoroughly it shattered expectations. Normal Type 2 supernova occur when massive stars collapse, their cores imploding into neutron stars or black holes as their outer layers blast outward in a single, spectacular explosion. The light curve, a graph of brightness over time, should show a sharp peak followed by a steady decline as radioactive nickel decays and the ejector cools. But IPTF-14 HLS's light curve looked like a seismograph during an earthquake, with violent surges and dips that defied explanation. Even more bizarre, archival images revealed the same star might have exploded 50 years earlier, surviving a supernova only to do it all over again. Theories scrambled to keep up. One leading idea invoked a magnetar, a neutron star with a magnetic field so intense it could inject energy back into the expanding debris, rekindling the explosion like a cosmic bellows. But even this extreme model struggled to explain the sheer duration and erratic rebrightening. Another hypothesis suggested a pulsational pair instability supernova, where a star so massive, possibly over 100 solar masses, becomes unstable and undergoes repeated explosive eruptions before its final collapse. These rare events, previously theoretical, might leave behind no compact remnant at all, just an empty cavity where a star once roared. Then came the kicker. Spectral analysis revealed another anomaly. Most supernovae show hydrogen lines fading as the expanding gas thins. But IPTF-14 HLS's hydrogen lines strengthened over time, suggesting it was surrounded by dense, pre-existing shells of material debris from earlier eruptions hurled into space years before the final explosion. It was as if the star had been coughing off its outer layers in violent fits before its catastrophic finale. The implications ripple far beyond one stubborn supernova. If stars like IPTF-14 HLS exist, they challenge our understanding of stellar life cycles, suggesting some massive stars might die in slow-motion tantrums rather than single violent collapses. Surveys are now hunting for similar events, probing whether this was a freak cosmic outlier or the first recognized member of an entirely new supernova class. And with next-generation telescopes like the Vera Rubin Observatory set to scan the skies deeper and faster than ever, we might soon find more of these undead stars lurking in the darkness, rewriting the rules of stellar demise one explosive heartbeat at a time. The cosmos has a way of humbling even our most confident theories. Just when we think we've mapped the life and death of stars, along comes a rebel like IPTF-14 HLS, a cosmic phoenix that burns, fades, and burns again, forcing us to question everything we thought we knew about how stars live, die, and sometimes refuse to stay dead. Dark energy was supposed to be the universe's great equalizer, an invisible force accelerating the expansion of space, stretching galaxies apart like dots on an inflating balloon. But when scientists with the Dark Energy Survey mapped the cosmos in unprecedented detail, they stumbled upon something unsettling: weak gravitational lensing, the subtle warping of light from distant galaxies as it passes through massive cosmic structures revealed a universe growing too slowly. The data showed large-scale structures forming less densely than Einstein's theory of relativity predicts, a discrepancy so persistent it's now called the sigma-8 tension. Here's why this matters. Sigma-8 represents the clumpiness of the universe, how matter congregates into galaxies and clusters over time. According to the standard cosmological model, dark energy's push and dark matter's pull should balance this growth in a precise way. But the Dark Energy Survey's weak lensing maps, created by analyzing distortions in the shapes of 200 million galaxies, paint a different picture. The universe appears smoother, more diluted, as if some unseen hand is suppressing the formation of cosmic structure. It's like baking a cake where the batter refuses to rise, except this cake is the entire observable universe, and we can't figure out why it's staying flat. The sigma-8 tension isn't just a minor hiccup. It joins another growing crisis in cosmology, the Hubble tension, where measurements of the universe's expansion rate disagree depending on whether we use nearby supernova or the cosmic microwave background. Together, these anomalies suggest our understanding of gravity, dark matter, or dark energy might be fundamentally incomplete. Some theorists propose dark energy isn't constant but evolves over time, subtly altering how structures form. Others wonder if dark matter interacts with itself in ways we haven't accounted for, slowing the growth of galactic filaments. The most radical ideas even flirt with modifications to Einstein's theory of general relativity itself, suggesting gravity might behave differently on cosmic scales. What makes this discovery so electrifying is how it emerged from sheer technological audacity. The Dark Energy Survey's 570-megapixel camera, mounted on a telescope in Chile, spent 6 years capturing light that had traveled for billions of years. By studying how that light bent around invisible mass, scientists reconstructed a three-dimensional map of the cosmos's hidden scaffolding. The precision is staggering, detecting distortions 1/10,000th the width of a galaxy, equivalent to measuring a human hair from 2 miles away. Yet for all its sophistication, the survey's findings leave us with more questions than answers. Are we seeing the first cracks in our cosmic models or just statistical noise? Upcoming projects like the Vera Rubin Observatory's Legacy Survey of Space and Time will sharpen these weak lensing maps exponentially, scanning 37 billion galaxies over a decade. If the tension holds, we might be on the brink of a paradigm shift, one that redefines not just dark energy, but the very fabric of spacetime. For now, the sigma-8 tension stands as a humbling reminder: the universe doesn't owe us consistency. Every time we think we've pinned down its rules, it throws a curveball, daring us to look deeper. And in that uncertainty lies the thrill of discovery, the chance to rewrite the textbooks, one anomalous data point at a time. In the frozen outskirts of our solar system, beyond the orbits of Neptune and Pluto, lies a realm of ancient relics, the Oumuamua cloud, a vast shell of icy bodies left over from the solar system's birth. And in 2021, astronomers Pedro Bernardinelli and Gary Bernstein uncovered its king, a monstrous comet now bearing their names, Bernardinelli-Bernstein. This isn't just another dirty snowball, it's a behemoth, the largest Oumuamua cloud object ever discovered, with a nucleus estimated to span 140 kilometers across. To put that into perspective, that's 7 times wider than Halley's Comet and twice the size of Hale-Bopp, the legendary Great Comet of 1997. If Bernardinelli Bernstein were placed next to Hale-Bopp, it would dwarf it like a boulder looming over a pebble. But size isn't the only jaw-dropping feature of this cosmic wanderer. Its orbit tells a story of epic voyages. Unlike most comets which swing by the sun every few decades or centuries, Bernardinelli Bernstein takes millions of years to complete a single orbit. The last time it visited the inner solar system, our ancestors were barely walking upright, and when it returns, Earth's continents might look completely different. Right now, it's barreling toward us sort of. At its closest approach in 2031, it'll still be just beyond Saturn's orbit, too distant to see with the naked eye. But for astronomers, that's a front-row seat to study a primordial time capsule, untouched since the dawn of the solar system. What makes this mega comet so intriguing isn't just its scale, it's what it represents. Most comets we observe come from the Kuiper belt, a region just beyond Neptune. Bernardinelli Bernstein, though, hails from the Oort cloud's deepest reaches, where temperatures hover near absolute zero. That means its chemistry could be pristine, offering clues about the raw ingredients that built our solar system. Spectroscopic studies have already detected traces of carbon monoxide and other volatiles, hints that this comet's ices might differ from those of its smaller cousins. Then there's the big question: could it have played a role in Earth's past? Some researchers speculate that during earlier flybys, gravitational tugs from Bernardinelli Bernstein might have nudged other comets toward the inner solar system, potentially contributing to Earth's water supply, or even to extinction-level impacts. It's a cosmic game of billiards where one gentle nudge can echo across millennia. As telescopes like the Vera Rubin Observatory come online, we'll get unprecedented views of this icy giant. Will its surface crack under the sun's warmth, revealing hidden geysers? Could its composition rewrite our understanding of the Oort cloud? Whatever we learn, Bernardinelli Bernstein serves as a humbling reminder. Even in our own cosmic backyard, there are still giants left to discover, sleeping titans stirring slowly in the dark. And as this one glides silently toward the sun, it carries with it secrets older than the planets themselves. Just when we thought black holes couldn't get any stranger, astronomers found one that defies expectations, not by being monstrously large or violently active, but by being bafflingly small and eerily quiet. Dubbed the Unicorn, this cosmic oddity holds two remarkable titles. It's the closest known black hole to Earth, lurking just 1,500 light-years away, and it's also one of the tiniest ever discovered, a mere 3 times the mass of our Sun. That's so small, it teeters on the edge of what physics says is possible for a black hole. But what makes the Unicorn truly extraordinary isn't just its size, it's how hidden it was. Unlike its counterparts that devour nearby stars or spew X-rays, this black hole is dormant, invisible, detectable only by the subtle way it tugs on a neighboring red giant star like an unseen puppeteer. The discovery came from a stroke of cosmic detective work. Astronomers weren't even hunting for black holes, they were studying the red giant's light spectrum when they noticed its light periodically Doppler shifting, as if an unseen object were yanking it back and forth. The math revealed a gravitational dance. The star orbits something every 60 days, something with enough mass to be a black hole but emitting no light or radiation. It's like finding a ghost by the footprints it leaves in the snow. The Unicorn's existence challenges our understanding of how black holes form. Most stellar mass black holes we've found are at least 5 times heavier than the Sun, born from the collapse of massive stars. But a 3-solar mass black hole, that's pushing the limits of stellar physics, suggesting either a star collapsed unusually gently or we're missing a whole population of these diminutive dark objects. What's equally fascinating is how we found it. Traditional black hole hunters rely on X-ray telescopes to spot accretion disk superheated gas swirling into oblivion. But the Unicorn, like an estimated 99% of black holes, is quiescent, not actively feeding. To uncover these silent giants, astronomers now use gravitational influence as their primary tool, tracking the wobbles of companion stars or disruptions in star clusters. It's a paradigm shift, proof that the universe's most enigmatic objects often hide in plain sight, their presence betrayed only by the faintest gravitational whispers. The unicorn's companion star adds another layer of intrigue. The red giant is slowly being stripped of its outer layers by the black hole's gravity, a process that could eventually ignite X-ray emissions if enough material falls inward. For now, though, this system is a cosmic still life, a black hole content to lurk in the shadows, its existence a quiet rebellion against the violent stereotypes of its kind. And if there's one thing the unicorn teaches us, it's that the universe loves to surprise us. For every raging, galaxy-shaping black hole, there might be hundreds of these silent phantoms, drifting unseen through the cosmic dark, waiting to be discovered by those patient enough to look beyond the light. In the summer of 2017, headlines exploded with a claim that sent shockwaves through the astronomy community. Alien signals had been detected from the Andromeda galaxy. A team of amateur astronomers calling themselves the Russian UFO Research Station announced they'd picked up a powerful, repeating radio burst from M31, our nearest galactic neighbor, using nothing more than a repurposed Soviet-era radio dish. The story spread like wildfire, amplified by breathless media coverage. News outlets played eerie audio clips of the supposed signal, a pulsing, almost melodic sequence of beeps that sounded like something straight out of a science fiction movie. For a brief, electrifying moment, it seemed humanity might have just made first contact. But here's the twist: the signal was a hoax. Within days, professional SETI researchers at institutions like the Breakthrough Listen Project debunked the claims. The frequency matched no known natural cosmic source, and the signal's characteristics, like its failure to disperse across interstellar distances, betrayed its earthly origins. Investigators traced the audio to a poorly concealed digital synthesis, complete with telltale artifacts of artificial generation. Yet despite the swift debunking, the story lingered in conspiracy circles, morphing into a tale of government suppression and hidden truth. The Andromeda incident became a textbook case of how misinformation spreads in the digital age, where a compelling narrative often outweighs verifiable facts. What makes this episode so fascinating isn't just the hoax itself, but what it reveals about real SETI protocols. When professionals search for extraterrestrial signals, they follow rigid verification steps. First, they rule out terrestrial interference. Cell towers, satellites, or even microwave ovens can mimic alien transmissions. Next, they check for known astrophysical sources like pulsars or masers. Only after exhaustive elimination do they escalate findings, often through the International Academy of Astronautics' rigorous confirmation process. The Andromeda signal skipped every one of these safeguards, yet its sensational appeal overrode skepticism. The incident also highlights a growing tension in modern astronomy. With radio telescopes becoming cheaper and data-sharing platforms more accessible, amateurs are contributing meaningfully to discoveries like the crowd-sourced detection of fast radio bursts. But this democratization comes with risks. Unverified claims can undermine public trust in legitimate science, especially when debunking lags behind virality. The Andromeda hoax wasn't just harmless fun. It diverted attention from actual SETI efforts like the ongoing monitoring of Proxima Centauri or the mysterious WOW signal follow-ups. Yet there's an unexpected silver lining. The hoax reignited interest in how we'd truly recognize an alien signal. Unlike the Andromeda recording's sci-fi cadence, most experts agree a genuine transmission would likely be narrowband, devoid of musicality, and persistent across observations. It might even carry embedded mathematical patterns, a cosmic hello designed for universal comprehension. Projects like Breakthrough Listen now use machine learning to sift through millions of radio channels, filtering out human-made noise while hunting for these subtle cosmic needles in the haystack. So while the Andromeda signal fizzled into obscurity, its legacy endures a cautionary tale about the allure of easy answers in a field built on patience and rigor. The next time a headline screams "aliens found," remember, the universe's greatest mysteries won't be solved in a soundbite. They'll emerge through years of meticulous observation, cross-verification, and the quiet persistence of scientists who know that truth, unlike a viral hoax, can't be rushed. And if you're wondering what a real alien signal might sound like, don't trust the dramatic loops from conspiracy forums. Trust the static, the white noise between the stars. Because somewhere in that cosmic silence, if we listen carefully enough, the first genuine message might already be waiting. Deep in the frozen fringes of our solar system, far beyond the orbit of Neptune, a tiny world dances to the rhythm of an unseen conductor. Discovered in 2015 and nicknamed the Goblin, this dwarf planet, officially designated 2015 TG387, holds secrets that could rewrite our understanding of the solar system's outer limits. What makes this icy speck, barely 300 kilometers wide, so extraordinary isn't just its distance, it's the way it moves. The Goblin's orbit stretches so far, it takes 40,000 years to complete a single trip around the Sun. At its closest, it's still twice as distant as Pluto. At its farthest, it ventures over 2,000 times farther from the Sun than Earth. But the real kicker: the Goblin's path isn't just big, it's tilted, angled sharply away from the plane of the solar system, as if something massive yanked it off course. This bizarre trajectory is exactly what caught astronomers' attention. When researchers plotted the Goblin's movement alongside other extreme trans-Neptunian objects, icy worlds like Sedna and 2004 VP113, they noticed a chilling pattern. These objects' elongated orbits all seem to cluster in the same region of space, their closest approaches to the Sun huddled together like campers around a fire. The odds of this happening randomly, less than 1 in 1,000. The most plausible explanation: the gravitational hand of an unseen giant, a hypothetical Planet 9, lurking in the darkness, herding these small worlds into their peculiar orbits through its immense pull. Here's how the math works. Planet 9, if it exists, would be a super-Earth about 5 to 10 times more massive than our world, orbiting roughly 20 times farther from the Sun than Neptune. Its gravity would act like a cosmic broom, sweeping smaller objects into aligned, high-inclination orbits over billions of years. The Goblin fits this model perfectly. Simulations show that without Planet 9's influence, the Goblin's orbit would be statistically impossible, like rolling dice and getting the same number 20 times in a row. But with Planet 9 in the equation, the Goblin's path suddenly makes sense, falling neatly into place like the final piece of a celestial jigsaw puzzle. Yet the Goblin isn't just evidence for Planet 9, it's also a roadmap to finding it. Because the dwarf planet's orbit is so stretched out, it spends most of its time drifting slowly at aphelion, its farthest point from the Sun. That's where Planet 9's gravity would be strongest, subtly tweaking the Goblin's position over centuries. By tracking these minute deviations, astronomers can triangulate the hidden planet's possible location. It's like watching a single leaf tremble in a pond to deduce where the stone was thrown. Current estimates suggest Planet 9, if real, might lie somewhere in the constellation Orion, but pinpointing it will require catching its gravitational whispers in the motions of more distant objects like the Goblin. The implications are staggering. If Planet 9 exists, it would be the first new major planet discovered in our solar system since Neptune in 1846, and the first ever found through mathematical prediction since Pluto in 1930. But unlike Pluto, this world would be a genuine heavyweight, large enough to clear its orbital neighborhood and reshape our understanding of planetary formation. Some theories suggest it could be a rogue exoplanet, captured by the Sun's gravity during the solar system's chaotic infancy. others propose it formed closer in before being flung outward by gravitational encounters with Jupiter or Saturn. Whatever its origin, Planet 9 would force us to redraw the map of our cosmic backyard. For now, the goblin remains a tantalizing clue, a breadcrumb in the darkness pointing towards something far grander. Every new extreme trans-Neptunian object discovered tightens the noose around Planet 9's possible location, each one adding another day to point to the celestial manhunt. And as telescopes like the Vera Rubin Observatory come online, capable of scanning the entire visible sky every few nights, the odds of spotting Planet 9, or ruling it out once and for all, grow ever higher. Until then, the goblin and its kin will keep whispering their secrets, reminding us that even in our own solar system, the most profound discoveries might still be hiding in the shadows. The cosmic microwave background, the afterglow of the Big Bang, should be smooth like the surface of a calm lake. But when scientists mapped its faint whispers across the sky, they found something impossible. A sprawling, icy blemish in the constellation Eridanus, a region so cold it defies all expectations. This is the cosmic cold spot, an anomaly spanning nearly 2 billion light-years where temperatures dip mysteriously below the surrounding cosmos. At first glance, it might seem like a statistical fluke, a random blip in the data. But the odds of such a colossal cold patch forming naturally, less than 1 in 50. This isn't just a cosmic hiccup, it's a glaring crack in our understanding of the universe's infancy, and some theorists believe it might be the first tangible evidence of a collision with another universe. The discovery came into sharp focus with data from the Planck satellite, which mapped the CMB in unprecedented detail. The cold spot isn't just cold, it's structured, with a distinct, almost circular boundary that suggests something more than random chance. One leading explanation dips into the multiverse theory. If our universe is just one bubble in an endless froth of parallel realities, the cold spot could be a bruise left by a neighboring cosmos brushing against ours during the Big Bang. Picture 2 soap bubbles barely touching; their surfaces would dent slightly at the point of contact. In cosmic terms, that dent would siphon energy away from the collision zone, leaving behind a cold, hollowed-out region in the CMB. But not everyone's convinced. Skeptics argue the anomaly might stem from something far more mundane. A vast supervoid, an underdense region of space where fewer galaxies mean less gravitational pull, stretching light passing through it and cooling the CMB in a process called the integrated Sachs-Wolf effect. The problem: surveys like the Dark Energy Survey have struggled to find a void large or empty enough to explain the cold spot's extreme chill. The math just doesn't add up unless we're missing something fundamental about how voids interact with the CMB. Then there's the wild card. What if the cold spot isn't an error or an imprint from another universe, but evidence of exotic physics? Some quantum gravity models suggest space-time itself might have a frothy, granular texture at the smallest scales, and under rare conditions, these quantum fluctuations could magnify into macroscopic anomalies. It's a long shot, but if proven, it would mean the cold spot isn't a scar from a cosmic collision. It's a glimpse into the quantum machinery underpinning reality. The debate rages on because the stakes are so high. If the cold spot is proof of a parallel universe, it would revolutionize cosmology, offering the first empirical evidence for the multiverse. If it's a supervoid, it challenges our models of large-scale structure. And if it's neither, well, that might be the most exciting outcome of all, a sign that the universe still holds physics we've yet to dream of. For now, the cold spot remains a tantalizing enigma, a frozen fingerprint on the fabric of the cosmos, daring us to decipher its origins. And as new telescopes probe deeper into the CMB's subtle patterns, one thing's certain: the universe's coldest mystery might just be its hottest clue. From the Wow signal's eerie radio whisper to the cosmic-scale mystery of dark flow, from the fleeting brilliance of fast radio bursts to the mind-bending implications of the KBC void, we've journeyed through 25 of the universe's most bizarre and baffling phenomena. Each one defies expectations, shatters assumptions, and forces scientists to rewrite the rulebook. But here's the beautiful truth: these aren't just cosmic oddities, they're the cracks in our understanding, the places where the universe nudges us toward deeper questions and bolder discoveries. Take Oumuamua, the interstellar visitor that accelerated without explanation. It didn't just challenge our ideas about comets, it reminded us that the cosmos is constantly sending surprises our way, if only we're watching closely enough. Or consider the Fermi Bubbles, towering over the Milky Way like silent monuments to a violent past we're only beginning to piece together. Even failures to solve these mysteries, like the Phoenix Lights hoax, teach us something vital. The pursuit of truth requires rigor as much as wonder. What ties these phenomena together isn't just their strangeness, it's their power to push science forward. The missing baryon problem led us to the hidden cosmic web of the WIM. The unicorn black hole rewrote the playbook for how we hunt invisible objects, and the cold spot, whether it's a supervoid, a multiverse bruise, or something entirely new, it proves the universe still holds puzzles we haven't even thought to ask about yet. So here's the real takeaway: the universe wants to surprise us. Every time we think we've got it figured out, it throws a curveball, a zombie star that refuses to die, a dwarf galaxy made mostly of dark matter, or a cosmic cold spot that might just be a window into another reality. These aren't roadblocks to knowledge, they're invitations to dig deeper, stay curious, and embrace the sheer unpredictability of the cosmos. As we wrap up this journey, remember the weirdest discoveries often lead to the biggest breakthroughs. Maybe one of these 25 mysteries spoke to you more than the others. Was it the potential alien megastructure of Tabby's star, the gravitational enigma of the Great Attractor, or the spine-tingling possibility that Planet 9 is lurking in our solar system's shadows? Drop your favorite in the comments and let's keep the conversation going. Because the universe isn't just bigger than we imagine, it's weirder, wilder, and more wonderfully inexplicable than we've dared to dream, and the next great cosmic revelation. It's out there, waiting for someone like you to look up and wonder.